In this lesson, we are going to look at time and work problems. If Alex and Eric can finish a work in 2 hours working together, and Alex alone can finish the work in 3 hours, how many hours will it take Eric alone to complete the work? Let A denote Alex and E denote Eric. We are going to use the simple trick of work rate to solve this problem. So we know that Alex and Eric can finish the work in 2 hours. So we can say that combined work rate, so combined work rate per hour is equal to 1 on the number of hours they can use together is 2. So 1 on 2. Then we can say that Alex work rate per hour is equal to 1 on. So Alex alone can use 3 hours. We have Eric work rate per hour, which is equal to 1 on. We don't know the hours Eric can use to complete the work. So 1 on E. Therefore, the work rate for Alex plus the work rate for Eric is equal to the combined work rate. So that is 1 on A plus 1 on E is equal to 1 on A E. So the work rate for Alex plus the work rate for Eric is equal to the work rate for their combined. So this gives us the work rate for Alex is 1 on 3. So 1 on 3 plus 1 on E, which is equal to 1 on their combined work rate is 1 on 2. So we have 1 on 3 plus 1 on E equal to 1 on 2. So let's take the LCM. So the LCM can give us 6E. So multiply by 6E and then multiply the whole of this. Then we multiply the whole of this by 6E. So when we expand, we're having 6E on 3 plus 6E on E equal to 6E on 2. So we expand the bracket. So this gives us 3 into itself 1, 3 into 6 is 2. So we have 6, 2E plus E will cancel E, giving us 6 equal to, we have 2 into itself 1, 2 into 6, that's 3E. So regrouping, we have 6 equal to 3E minus 2E. So therefore, E is equal to 6. So thus, Eric can finish the work in 6 hours. Let's look at another example. It takes Felix 4 hours to complete weeding a piece of land and 6 hours for Ben to complete weeding the same piece of land. How many hours will it take Felix and Ben to complete weeding the piece of land working together? So we show that let F denote Felix and B denote Ben. So we are going to look at the work rate per hour that Felix can use to finish weeding. So Felix work rate per hour is equal to 1 on 4. So you can use 4 hours to complete. So the work rate per hour is 1 on 4. We look at Ben work rate per hour is equal to, so Ben 2 can use 6 hours to complete within the same piece of land. So the work rate is 1 on 6. Then let's look at their combined work rate. So combined work rate per hour is equal to, we don't know the number of hours they can use weeding together. So that is 1 on FB. But we can say that let FB equal to Y. So this is equal to 1 on Y. So therefore, we know that the Felix work rate plus Ben work rate is equal to their combined work rate, which is FB. So this gives us, so we have 1 on F plus 1 on B equal to 1 on FB. But we know that the work rate for Felix is 1 on 4 plus the work rate for Ben is 1 on 6 equal to their combined work rate, which is 1 on Y. So this gives us, the LCM here can give us 12Y. So we have 12Y multiplied by 1 on 4 plus 1 on 6 equal to 1 on Y multiplied by 12Y. This gives us 4 into itself 1, 4 into 12, which is 3Y plus 6 into itself 1, 6 into 12, 2. So we have 2Y equal to, Y will cancel Y, giving us 12. So we have 5Y equal to 12. So let's take multiplicative inverse of 5. So we have 1 on 5 multiplied by 5Y equal to 1 on 5 multiplied by 12. So therefore, Y is equal to 12 on 5, which is equivalent to 2.4 hours. So they both can complete the work in 2.4 hours. Let's look at another question. Alex and Felix can paint a room in 4 hours working together. If Alex can complete the work 2 times faster than Felix working alone, how many hours will it take Felix alone to paint the room? So we said that let A denote Alex and F denote Felix. So they can complete the work working together in 4 hours. So we combine work rate per hour is equal to 1 on 4. But take note, if Alex can complete the work 2 times faster than Felix alone, how many hours will it take Felix to complete? So that means if Alex can complete the work in 2 hours, then it will take 4 hours for Felix to complete the work. And if Alex can complete the work in 3 hours, it will take Felix 6 hours to complete the work. So we can say that let what be the hours Alex can complete the work. So therefore, Alex work rate per hour is equal to 1 on Y. And we know that Felix work rate per hour is equal to 1 on 2Y, because if Alex can complete the work in Y hours, it will take 2Y hours for Felix to complete the work. So therefore, we know that the work rate for Alex plus the work rate for Felix is equal to their combined work rate working together. So 1 on AF. So we have 1 on A plus 1 on F equal to 1 on AF. This implies that so the work rate for Alex is 1 on Y plus the work rate for Felix is 1 on 2Y equal to the work rate for their combined is 1 on 4. So the LCM here will give us 4Y. So we have 2, 4. So the LCM will give us 4 and we have 1. So this gives us 4Y multiplied by 1 on Y plus 1 on 2Y. And this gives us 1 on 4 multiplied by 4Y. This gives us Y plus 2 equal to Y. So therefore, Y is equal to 6. But note that this is Alex. So Alex alone can complete the work in 6 hours. And then Felix alone can complete the work in 12 hours. So don't forget, Alex can complete the work 2 times faster than Felix. So if Alex can complete the work in 6 hours, that means it will take Felix 12 hours to complete the work. And this is all about time work problems. This is the simple approach you can use to solve.